Welcome to this video on compound interest and repeated percentage change. You can find all the questions, clues and solutions in the handy PDF booklet which is available at mathsupgrade.co.uk. These are all calculator questions. The first one starts off about Derek buying a house and selling a house for a certain profit. We need to work out his percentage profit. So these first 3 marks don't involve compound interest. Those involve applying this formula. Essentially, I need to find the change in the value of his house and then write that as a fraction over the original amount. And then to turn it into a percentage, I need to times it by 100%. So since the change is the difference here, the difference is just £4,500. If I divide that by 150,000 and times it by 100%, I'll get 3%. So that's the first 3 marks. In the second part of the question here, this is my compound interest question. Invests that final amount for 2 years at 4% per year compound interest. Work out the value of the investment at the end of 2 years. So what this means is he gets 4% interest at the end of the first year on that amount, and then that's added to that amount, and then he gets 4% interest on that whole new amount in the second year as well. So the interest compounds. So to set it up, I'm just going to remember that the multiplier for 4% interest is 100%, which is what he started with, plus 4%, which is 104%. 104% as a fraction is 104 over 100, which is 1.04. So 1.04 is my percentage multiplier. When I multiply that by the original amount, each time I multiply by the original amount, that represents 1 year. Since I'm going to do it for 2 years, I can just square this percentage multiplier, since that's basically putting it to the power of 2, which means for 2 years. So in essence, I'm doing this 154,500 times 1.04 times 1.04 again. In other words, times 1.04 squared. With a calculator, that's straightforward to do. I need to make sure I write it to 2 decimal places and with a pound sign at the start as well. That question there is worth 3 marks, so the whole question there is worth 6 marks. In question 2, I'm told that Sakira invested £3,550 in the savings account for 3 years. She was paid 2.6% per year compound interest for each of the first 2 years. She was paid R% interest for the 3rd year. She had £3,819 in savings account at the end of those 3 years. Work out the value of that interest rate for the 3rd year. Give your answer correct to 1 decimal place. So this question is 3 marks. The way I'm going to do this question is I'm going to work out how much she had in her account at the end of the 2 years. Then once I know that, I can then work out her interest rate for the 3rd year, since I know the final amount and I know the starting amount of that 3rd year. So let's set this up. Remember, for compound interest, this is the formula we need to use. The new amount at the end of a time period is equal to the original amount at the start of the time period times by the multiplier to the power of time. So at the end of 2 years, originally she had 3,550, so at the end of 2 years she would have had that multiplied by 2.6% as a percentage multiplier, which is 1.026, and that's to the power of 2 because it's applied for 2 years. So with the calculator, that would be 3,737. Now in the final year, we don't know her interest rate, so this multiplier is missing here, but we do know she ended up with £3,819.21, and she started a 3rd year with 3,737. So I'll set up an equation here. I just need to work out this missing value. To work out that missing value, I'm going to do the inverse of multiply by 3737, which is divide. So 3,819 divided by 3737 gives 1.022. 1.022 is the same as 102.2%. So if I need to work out the percentage interest rate, I just subtract 100%, which gives me 2.2%. So that question there was worth 3 marks. In question 3, I'm told that Katie invests £2,000 in a savings account for 3 years. The account pays compound interest at an annual rate of 2.5% for the first year, and then a certain percentage rate for the second and third years. There's a total amount of £2,124.46 in the savings account at the end of the 3 years. Work out the rate of interest in the second year. So to do this, I'm going to set up my formula in this way again, and then I'm just going to find the multiplier, which represents 2.5%. So since 2.5% is added to the original amount, that's 102.5%, which as a percentage multiplier is 1.025. So in year 1, her deposit was 2,000, that's what she put into the bank. The percentage multiplier is 1.025, so multiply them together, and after just 1 year the power is 1, so it's 2,050. Now in years 2 and 3 she gets a certain interest rate, and it's constant for those 2 years, and that's what we need to work out. So I know the final amount at the end of those 3 years, it's given in the question here, 2,124. I know the starting amount at the start of the second year, which is what I've worked out here. And what I don't know is I don't know the percentage multiplier. So I don't know what's here, but I know it's an X percent. And so an X percent I've just represented with 100 add X divided by 100. This here just converts that X percent into a multiplier. For example, if it was 1%, that would be 101 divided by 100, which is 1.01. If it was 50%, it would be 150 over 100, which is 1.5. I know also that the time period here is 2 years. So I've set up an equation here. I now need to work out the value of x. To work out the value of x, I'm going to divide both sides by 2050, since that's the inverse of multiplying by 2050. So divide by 2050, and I get this value 1.036. So 1.036 is this squared. The inverse of squaring is square rooting. So let me square root both sides of this equation. That gives me 1.018. And that represents 100 add x divided by 100. To solve this, I'll skip a few steps here since I've run out of working out space. But I'm just going to multiply by 100 and then subtract 100. So if I multiply by 100, that'll give me 101.8. And then if I subtract 100, that'll give me 1.8. So the percentage interest rate for the second and third years was 1.8%. That's 4 marks for that question. In part B, I'm told that she goes to work by train. The cost of a train ticket increases by 12.5% to £225. Work out the cost of a weekly train ticket before that increase. So this question actually involves reverse percentages. I'm told the final cost of a ticket, and I'm told the percentage rate. I'm not told the original amount. I need to work out the original amount. So to work out the original amount, I'm converting that 12.5% into a multiplier. That's 1.125. So something has been multiplied by 1.125 to give £225. To work out the original cost, I should do the inverse of that, which is dividing by 1.125. So if I do 225 divided by 1.125 with a calculator, I'll get £200. Remember, I can check this by just multiplying it by 1.125. I should get back to 225. If you're not sure on how I've done this reverse percentages, be sure to look at my video clip on this channel on reverse percentages to give you further support. Question 4. This notice was in a car magazine. So the notice says that most new cars lose more than half their value in the first 3 years. So Paul bought a new car. The value of the car was £15,000. In the first year, the value of the car depreciated by 23%. After the first year, the value of the car depreciated by 18% each year. We need to work out if that notice in the car magazine was correct or not. So did his car lose more than half its value by the end of those 3 years? So in essence, what I'm going to do here is I'm going to apply the percentage multipliers repeatedly. The first percentage multiplier is given by this depreciation of 23%. Okay, so we're starting with 100%. If it depreciates by 23%, I'm left with 77%. So the multiplier here will be 0.77. And then after the first year, if it depreciates by 18%, then that's 100% subtract 18%. So the multiplier here will be 82%, which is 0.82. So let's apply those. So we're starting with 15,000, multiplying by 0.77, which gives me 11,550. And then for the second and third years, remember there's 2 more years here, I apply 0.82 to this new amount, and I apply it twice. So in other words, it's the time period of 2 for 2 years. So that gives me £7,766.22. So is that claim made by the magazine, is it correct? Half the original value would have been 7,500, right? So if it's worth less than 7,500, then the claim is correct. But it is worth just more than 7,500. So in other words, the claim is not correct. His car did not lose more than half its value by the end of those 3 years. So that question there was worth 4 marks. Question 5. The value of a van depreciates at the rate of 20% per year. Gary buys a new van for £27,500. After n years, the value of the van is £11,264. Find the value of n. In other words, find after how many years that value is correct. So let's set up this problem here. So the value of a van depreciates at 20% per year. That means it's going to be 100%, which is the original amount, subtract 20%, which leaves 80%. So the multiplier is 0.8. So using this formula, which I've used throughout this booklet, the new amount is 11,264. The original amount is 27,500, but this time the percentage multiplier is 0.8, and this time I don't know the time period. So I know everything here apart from the time period. So what I'm going to do here is I'm just going to apply this multiplier a repeated number of times until I get this value, 11,264. So the way you want to set this up on a modern scientific calculator to save yourself time is clear the screen and then type in 27,500, press the equals button, and that will then save it into the answer memory. Now clear the screen once more, press the answer key, and then type in multiply by 0.8. Now each time you press equals, it comes up with the new value after another year. So if you press equals once, it'll be 22,000. Press equals a second time, 17,600. Press equals a third time, 14,080. Press equals a fourth time, and it comes up with this value that we're given here, 11,264. In other words, after 4 repeated uses of that multiplier, then we get our value. So that represents 4 years. N equals 4. That question there was worth 2 marks. Question 6. Helen invested £6,000 for n years in a savings account. She had 3% compound interest each year. At the end of a certain number of years, Helen had £7,379.24 in her savings account. Work out the number of years. I'm showing you working, and this is 2 marks. So this is a very, very similar question to question 5. I know everything in this question apart from the time period. So here's the multiplier. It's 3% interest, so it's 100%, add 3%, which is 103%, which is the multiplier is 1.03. So the new amount is given to us here, the original amount is given to us, and the multiplier is what we've just written here. But we don't know over how many years this was. So you need to set up your calculator so it's straightforward to do, so you can save lots of time in the exam. After all, you're only given 2 minutes to do this question. So what you want to do on your calculator is you want to type in this original amount and save it in the answer memory. So type in 6,000 equals, and that is then in the answer memory on a modern scientific calculator. Then clear your screen, then press the answer key and multiply by 1.03. Now each time you press equals, you get 1 year's worth of interest added on to that original amount. So you press equals once, you get 6,180. Press equals twice, you get this value. keep pressing it until you get close to £7,379.24. You'll find you'll get that after 7 years. Might not be quite exactly the same decimal here, but obviously when you round it to 2 decimal places to the nearest penny, you'll realise that it is this value, and so it's 7 years worth of interest. So n equals 7, and that is 2 marks for that question. If you have any problems with any of these questions, be sure to check out my other videos on reverse percentages and just percentages of amounts, which is also on this YouTube channel. Thanks.